Thanks everybody for coming to our office hours session, talking about how to use JSON inside the database. And so with that, we'll let Beta take over and show us his cool stuff.
Cool, yeah, let's see how cool that's gonna be. Yeah, thank you, Blaine, for great introduction, and thanks everyone who's online. We've been pausing this for at least 2 sessions. I think I was traveling and I think a conference and some customers, and now we're back with another AskTOM on JSON. And I've been asking all the time for suggestions. Nobody really came back. I only had a few questions regarding SQL and PL SQL and JSON, so I thought I'm going to talk about this a little bit, how you can use JSON in PL SQL. But at the end, you can basically ask me any questions, and every time you can come up with suggestions, either shoot me an email or if you have subscribed to my Twitter account, just put it there and I may be able to read it. I don't check it daily. So what I've prepared for today is something you can actually do at home. Let me share my screen here. And it's something I put up on Oracle LiveSQL. So if you Google for LiveSQL, you will see a screen similar to this one, and you can search for scripts. Here it's not showing all the scripts, it's only showing the scripts I made, and I've prepared one for JSON and PL SQL. So I think if you click on scripts, you can Google them, and if you just type JSON and PL SQL, then you will see this one, and it should be public right now. So if you want to play with it, you can do this while I give this presentation. So let's run the script here, and then I can speak a little bit about what's happening. So today will be then basically mostly about PL SQL. So it's going to be very interesting for those of you that work with PL SQL. And it might be not so interesting for people who don't do PL SQL. So let's go here to my session. The warnings are, I think, all proper because I want to show some error cases as well. Yeah, so the idea is that in the Oracle database, we have this great feature called PL SQL, which allows you to do procedural logic inside the database. You can embed SQL statements, and you have the full control flow of programming languages, if then else, loops, etc. And you can move logic into the database. For example, if you want to do transactional stuff, or if you want to issue queries, then in many cases it's much faster to move the code to the data than instead to just query everything into the mid-tier and run your logic there. And we also have JSON in the database. So the question is, how can these two great things be combined? And I started with a very simple example here, just as a jump into the cold water, where I show you how easy it is to get something. And then after this simple example, we're going to dig into some areas specifically. So here, I'm not doing really an introduction to PL SQL, so I expect that you are somewhat familiar with procedures and functions, the syntax that PL SQL uses. If you have some very basic questions, just put them in the chat, and Blaine can interrupt me, or he may be able to answer them right away. So I don't know how familiar you are with PL SQL here. But we're basically...
One question in there that you might cover here in a second is, can you use an out parameter and return JSON that way?
Yeah, I guess so. And the reason is that we treat JSON here. So JSON is a text. We don't have a JSON data type in public available releases. So here our JSON comes in a textual representation as an input. It's a varchar 2. It might as well be a CLOB. But you could use that as a procedure or a function. And I'm pretty sure that you can also, if you are able to use a varchar as an out parameter, you can use JSON as an out parameter. So what are we going to do here? So I'm creating a procedure. It's called foo. It gets a varchar variable, which I call j, and that's the JSON. And inside here, this is the first interesting thing. There is something called O, and it's a JSON object T. So that's an object type that I have not defined anywhere, so it must come with a database, and it is indeed a type we've added in 12.2, so it's been out there for quite a while. So now I call this what we call constructor. I instantiate my O with the, this is like an object-oriented manner of doing it. I'm calling the type as a constructor, and I pass in the J, or our text JSON, and that will actually parse the JSON. It will also validate its syntax, and it will put the contents of J in my JSON object T. So now this is an in-memory representation of the JSON. It's no longer a textual representation, but it's basically C-backed, and it's using in-memory data structures. And now I have some methods that I can invoke on this object type, and one of them is called put. And I can put a new value that is associated with a new key, and then I call the conversion, or I print it. And in order to print my object, I have to convert it to a string. I have to serialize it. And that's what I'm doing here with a toString method. So the output is quite easy. I call the foo with an empty object, and what's being returned is an object which has a key called new key, and its value is new value. And if I call this with an object that is not empty, this one has a key called A and its value is 1, then we are adding something to a non-empty object. That's quite intuitive, I guess. What you can also see is that I've called here this object with a somewhat syntactic legal JSON. It's only somewhat because the A is not really in double quotes. So it's strictly not pure JSON, but it's something that we can make sense of. This is again where we do our Lex reading. We don't raise an error if we can make sense of it, unless you do a further check with is JSON and strict, then we wouldn't accept this as JSON. But when we generate or when we serialize something to text JSON, we make sure that it's proper JSON. Now we've escaped these, we double quoted this A value. So you won't get any JSON back that is kind of only Lex valid. But now if I call this on an array, remember JSON can be an object or array, I will get an error here, an invalid JSON type at our JSON object T. And that is quite understandable because we're trying to instantiate an object with an array. Okay, so what can we do? We can obviously create another function called, I think it's actually the same name here. And instead of an object, we use an array. So instead of array, object T, we have array T, and I call the constructor on the array type. And now I have an array here, also in an in-memory representation. Now instead of a put with a key value pair, I could, for example, do an append. So the array is somewhat the equivalent of a list or of an enumeration of values, so I could append a new value to it. And if I call the foo with my empty array, I see that this procedure adds the new value to it and serializes it. So this is, I believe, quite easy. I have my objects and my arrays, but that's not all of it. Imagine you have an object and you do a get call. So you're basically getting a JSON value back. So that value could be an object, it could be array, but it could also be a scalar value. You don't know if you invoke a get on an object, you don't necessarily know what its value type is. So this is why we've created this element T. So now what is the element?
Real quick, a question right there, Beta. I think I know the answer to this anyway, but I'll pass it on. So when you call that function as execute foo and just pass in 43, it throws an error.
Yeah, it would throw a similar error.
Yeah. So it's going to throw an error on the line where it's trying to create the object.
Yes, exactly.
Parse the object because it's not valid JSON. But then the next, it says it looks like, however, the object O is still created. Otherwise, the O.put would have failed. Is this correct? So does it still create the O after it fails?
No, this would fail here. This would fail. the constructor fails if this is not a string representation of an object.
Yeah. And so at that point, it would throw an exception and not continue on, just like with regular PL SQL.
Exactly. And I think we're going to see it a few lines below. I think I have exactly that example here.
And
So
by the
now,
way, this is just regular PL SQL. It's the PL SQL parts of this. There's nothing fancy or extra. It's just JSON functions that work just fine.
It's absolutely PL SQL, but we've added these object types to it. And what I want to get to is to show you that these object types, object and array, are not standalone types, but they're actually in a type hierarchy under element T. So we have this JSON element T, and an element T or an element is either an object or it's an array or it's a scalar. Because this is what you would get back from a get call on an object, for example. If you say get me the value XYZ, we don't know whether it's an object, an array, or a string, or a number, or whatever, but this is where this JSON element T comes because it's the common supertype. So it's a static supertype, which means you cannot instantiate it directly. You can't call a constructor on element T, because there is no such thing as something that's only an element T. Like an element is one of these subtypes. It's never only the supertype. But what you can do is there is a static function called parse, or a method called parse. And if you give it the JSON string, it parses it. And under the cover, it instantiates the object or the array. So this is what we're doing here. E is our element. We're parsing a string. And then we can ask the E, are you an object or are you an array? Or what's not shown here, are you a scalar? So now if we call this with the input of an object, it's just saying us, I'm an object. Or if I call this on an array, it's saying I am an array. So this is the simplest way how we can introspect what the JSON really is. Now we call it with something that is not JSON, and again, we get the error here. I think this is the same error you would get if you would put 4.3 in here, which I think was the question asked a few minutes ago. So that, I think, is something you need to understand if you work with these object types, that they build these object-oriented type hierarchy. So all of these types come, there is no package you need to install the moment you have 12.2.02 or later. These types are part of PL SQL, and you can use them exactly like here. There's nothing you need to install, or packages or grants or anything like this. So now let's play a bit with this. So if we know that something is an object here, we can now downcast it to its subtype. So I have a procedure here. It's called value info. Its input is a element T. And the first thing I do, we're gonna build on this function later on. So right now it's not making a lot of sense. All I want to show you is that if you know that your element is an object, or if it's an array, well, you can just treat it as an object or array or a scalar, and then you have the actual instance, or the actual instance of the subtype where you can work with. So what can we do, for example, if we have an array? So if we have an array, so now you see here that I wrote a procedure where the JSON is not passed in as a string, but instead I use one of these type names here as an input argument. I could also use them as output, but I just use them as input here. So A is an array. And now I can count the size of the array. And I can iterate over the array. And this is similar to JSON or JSON JavaScript, where the array position normally starts with 0, not with 1. That's a bit different than I think collections and PL SQL would typically start with 1. So there you would see 1 to the end, but here we start with 0. And then I do the get. I get the element at position I, And here I have to use the E because I don't know what the I is. We will later learn that there are overloads of this function where I can say get me this as a number, or get me this as a date, or get me this as an array. But if you don't know anything about the value, all you can do is get it as an element T. Now I could do what I've done previously. I could say, are you an array? Are you a scalar? And do further logic. But all I'm doing here is I convert it back to a string. So that is possible. I can serialize this value to a string and just print it. So I have my array position I, and this has a value here. I think we're going to see the actual examples where I call this a bit later. Maybe I need to reorder this a bit. But I wrote a similar thing for scalar. So we have our scalar type here. And I can have scalar.
One sec.
Oh, yeah, sure.
Jump to the next topic.
Yeah.
There's a follow-up to the previous question. It said in the first procedure, you did not call parse. Instead, you just used JSON object T and passed in the value. In this case, it's 43.
Yes.
So
what's the question?
So it says, but in the first procedure, you did not call parse. You instead just called JSON object T and passed it the value.
Right, that's correct. So basically, it's a different API. If we look at this here, I call the constructor of JSON array T. Then I have to make sure that J is really an array. Otherwise, I will see an error, as we've seen. So this
was referring to JSON object T up above.
Right, but it's the same. Whether it's JSON object or JSON array, it's the similar API.
So the constructor is basically expecting the thing that you're, so in that case, it's expecting a JSON object. If you pass it in just a value of 43, that's not actually a JSON object, so it should fail. If you pass it null, then
I think the natural thing to understand, or the intuitive thing to understand, are really the constructors. You have a constructor, you give it a value, which is the string serialization or the string representation of the same value, and it creates one from that. The problem with JSON element T is that there is no such thing as an element T. An element is either an object, an array, or a scalar. So there is no constructor. The contract with a constructor is that it yields you an instance of that type. But there can't be an instance of JSON element T. This is why we made it, I'm not sure if PL SQL calls it also static, but in Java you would call it a static type with a static function or a static method. So if we call this here, the instance of E will never be an element T, because there can't be an instance of element T. Under the cover, it's either an object or an array or a scalar. But we are handling them using the supertype. This is a bit of object orientation here.
So I may have missed the example when you called this, but so the question is, at some point you used JSON object T and you passed in only 43 and it did not raise an error. So you called JSON object T, single quote 43, single quote, somewhere, and it did not raise an error. I did not actually notice that. I was probably fiddling with Zoom at the time.
I'm not sure I called 43. I called here, where is it? I called X instead of 43, and that gave us the syntax error. But this was
in reference to JSON object T instead of JSON element T.
We had this one here where we called JSON, I think this is JSON object T, and we've called it with an array, and that says it's an invalid type here. I can look at the chat. Maybe I can. I don't have the chat window open. Actually, I would have to. How do I see the chat if I'm sharing this? No, I got it.
Go to the top of the screen and it'll drop down from the top. I think the root of the thing is when you call JSON object T, it's expecting if you're going to pre-build that with an existing JSON object, it's actually expecting J in the highlighted code to be a valid JSON object. So you could not just pass 43 because that's not a valid JSON object. You'd have to say A:43 or something along those lines.
Yes. So the constructor will yield an error right away if it can't make sense of what you put in.
So if you have a JSON parsing or JSON beautifier somewhere, and if you drop whatever you're trying to pass into JSON object T into that and it fails, it's also going to fail with JSON object T, if that makes sense. There are tools out there that'll validate your JSON.
Or yeah, but the tools might be stricter. The tools, there's, for example, jasonlint.com, which does validation.
Some of them are require the double quotes around the
exactly. Some of them require the double quotes. We have isJSON for that. So if you want to do a strict validation of your JSON, you would use isJSON with a strict parameter. But the rest of our stack is quite forgiving, meaning there's some syntax deviances that we accept. One of them is your key names don't have to be in double quotes.
As long as the whole object is in a string, is in single.
Yeah. Basically, if we can parse it without any ambiguity, we accept it. And the reason is we've seen some of these JSONs in the wild where people have put out key names without quotes, or some arrays which have a trailing comma at the end, or some numbers that start with a zero without that start with a comma without the zero in front. Things like this, that we're just fault tolerant, but it's never the case that there can be two different means of interpreting the data. So we can, let me just continue a bit here, and then we can do these other examples, or the 43 maybe in LiveSQL in the quick SQL window, because here I can't just modify it and run it. I would have to copy it into another window, and I think then I lose my session here. Let's just pause this question. I don't want to avoid them, but we could just run these examples afterwards and then see right away where the error is being raised. So now I'm not exactly sure where I was. I believe it was here, where I'm creating a few procedures which I want to call later, which do some introspection. Basically, they look into our object or arrays and do something with it. And I think I already explained this array thing here, where we can just loop over the array and get the items of these array just by using a get with the position. So the position is the means to get the values. Then for scalars, we can ask our scalar value, are you a number, are you a string, are you Boolean, are you a data? I only put these three out. And for the object, now it's getting a little more interesting here. We have also added something that's called a JSON key list. So given an object, so the object is being passed into this procedure, that's our O, I can call get keys. And this will give me an enumeration, or a V-array basically, of all the key names. So it's a V-array of strings that I can then use to just loop over them. So this is the normal way in PL SQL how you would iterate over a collection using the count. And here, this is the accessor, how you get the key at the position I. And again, here we're in PL SQL, so the positions start with 1. This is a bit confusing here in my example because the arrays start at 0 just because it's JSON. There's a bit of it's not really inconsistent. It's just like, what's the number of the first element? And in SQL, it's 1. Consequently, in PL SQL, it was chosen to be 1, but JSON just said the first item in the array has the position 0. And we try to obviously preserve the 0 in JSON. And this is just plain PL SQL here. So we just have this get keys. We have our V array. We're iterating over it. We're extracting the key. And then using this get call here and the key as the parameter, I extract the value that's associated with the key, and then I'm printing it. And when do I finally call it? Oh, I call it here. Yes, and this is now my main driver function here. I pass in my JSON as a string. It's a varchar. I parse it. to an element. I don't know what it is. Now I ask it, are you an object? Then treat my element as an object and call the object info procedure. Otherwise, if it's an array, cast my element as an array and call the array info function, or similarly to a scalar. And now if I call this JSON info on this input 1, 2, it's an object and it's 3, we see the array position, we're enumerating over it, and we see, for example, at the position 2, our value is this object A with a value 1. And you again see that for whenever we serialize the value, we do proper quoting or proper JSON generation. Similarly, if I call the same JSON info with an object as an input, we see that we are now iterating over all the keys, and that key B has the value false, for example. So now we wrote a function that takes object or arrays and handles them both. So you could obviously make this recursive. I thought about it for a while, but I thought I've already made it confusing enough. But you can basically call these functions or procedures recursively, and you can then, if you have an object of objects of objects, you could just inside here, you could just say on my item or on my element, if you're an object, now call object info again or call array info again, and then you make it recursive, and then you actually would also call the scalar info, which right now is not getting invoked. And the main reason is, or the only reason is that we don't allow top-level scalar values. So if I put a scalar value in here, it would again be the parse function that fails because a scalar value cannot be a top-level value. So JSON is either an array or an object and not a scalar value. So what's the message? What did I try to convey to you? I wanted to show you that using these, first of all, that there is this type hierarchy, the supertype element T, and that you can downcast it to the subtype using treat. And the second part of the message was that you have means to identify what your JSON consists of. What are the keys? How many keys are there? How big is an array? And how do I get the values out? Now, that was quite academic here. Next question is, how do I generate a JSON object or a JSON array from scratch? Meaning I don't receive something, but instead I want to create a brand new instance, maybe from relational data or just aggregating data into a JSON. So this is now not a procedure, it's just a block here, and I've declared an object and an array. And just by calling the type name, the constructor, I get an empty object back. So if I don't pass in any string argument as text JSON, I just get an empty object or an array back. Here I put the new in. This is kind of a bit of Java-like. I don't think this is needed. I think it's the same would happen if you just write O is JSON object. Now you have these put methods here. So I'm putting a key, the value is 1. And the next line, very meaningful, I put a value 2, but the key name is the same. So we can actually, whenever there is a print or a put line, I'm just scrolling down here. So after these two operations, I'm printing the object, and you can see, quite unsurprising, that we've overwritten our first value. So the this works like normal JSON or a normal map or hash table, that you have a key and a value, and if you put the key twice, it's overwriting it. There's also a has method, so you could ask o.has key, and depending whether key exists, you could conditionally do certain things. I haven't shown the has method here, but I will show you later the doc, and that is the full API or list of all the functions. Now for our array, we can append. I think the append is one means to put information in the array. It's basically at the end. Or you can put which means overwrite something at a given position. So we're adding true as a Boolean string, true as a string, and then 1, 2, 3. And then at position 4, 5, 6, at position 2, we put the value 4, 5, 6. So now where's position 2? This is 0, this is 1, this is 2. So we would expect that the 1, 2, 3 gets overwritten. And that's not happening. Why is that the case? True, true, 1, 2, 3. Append, now we would have 3 values. Which value gets overwritten? True, true. Oh, I think the put has shifted it. Interesting, interesting. So put moves the data, it appears so. Maybe there's a replace. I have to look it up. It's been a while since I've done this. I have to read up on the meaning of put. I had thought it would overwrite it on an array, but it appears it's just moving. It's just injecting its value there, like operating as an insert. You can do more than just appending or putting scalar values. You can also nest these structures into each other. So here we take our array and we put the object at the end, which means our array was this one, and now we append the object, which is this, to the end. So this is then the end result. It's the old array and the object being appended. And we can do the same with our object. We can take our object, add a new field called nested array, and place the array there. Keep in mind here that this A has been modified and has the object itself in here. So now we do see here, in this example, we have our key and we have our nested array. So this was our original key value 2, that is still here, but then we have our nested array, which is all of this value, including the object. Why is the object part of this? Because we've appended it here. So the message here is that it's quite easy using put and append to add values into your data. And we also support some data types that naturally do not occur in JSON. For example, dates and timestamps. So we have an example here. Again, we create an empty object, and I'm putting a field here, which is the date, or the name is date, and its value is the current date, the sysdate. And we're printing it, and you see now that the date is printed as a string here. This is because, unfortunately, JSON has no syntax to represent a date. So it's rendered here, or it's serialized as a string in ISO 8601 format. But we have now, instead of just the getters I've shown so far, which gets you an element T, we have these underscore data type getters. So there is get string or get Boolean, get object, get array, and there's also get date. So we can then get our date out of the JSON out as a SQL date type. So D is a date. So it's this way, it's quite easy to work with SQL data types that are not naturally supported by JSON. We do maintain some type information, although that's obviously lost if we serialize it back to a string. So now we're putting a new value, which is called data string. I put this in as a string here. And here I'm doing a normal get. I could also do a get timestamp, because that's what I actually want to do, but I've chosen here to just do a get. And again, because get has no underscore type name, it's an element T. So now I can convert this element T to the timestamp, and I get my timestamp value back. Here it's actually whether you do first a get and then a to timestamp, or whether you do in one step a get timestamp should actually be the same. So instead of these 2 lines here, I could also say just o.get timestamp and this thing here. Now, what happens if this cannot be converted to a timestamp? So I have a quite similar example here with the only difference that this string is not a valid ISO 8601 string representation. So again, I'm pulling it out. That won't fail because this is just a normal string. There's nothing bad about this from a JSON point of view. So our element T here will just be a normal string. But now if I call the toTimestamp method on it, this will actually error, but it's yielded as a null value. That's somewhat odd. But when we designed this, or we designed this to be aligned with the SQL functions like JSON table or JSON value, which have the behavior of being fault tolerant. So for example, if you do a JSON value and your path expression does not select anything in the data, you may remember that you get a null value back. And if you want an error instead, you have to put this error on error clause, which is optional to your queries. And something very similar is here, where we have this on error too. So there is different modes, and I think the one means raise all errors. So let's look at this example quickly. We create our object T. We put in the same string, which is an invalid ISO. It's not a valid date representation. Then I get this value out as an element T. But now I'm modifying the element T, saying like any operations here which yields or which leads to an error, I want that to be raised. I don't want the null behavior here. So now this toTimestamp will give you an error. It's a bit, I think, most people working with PL SQL would question this, saying that if there is an error, it should immediately be raised, or at least the default should be different. Or if there is an error and I don't want it, I want to do my own handling of the error using exception handler or whatever. But this is following kind of the precedence of JSON value and JSON table, so that if you get a null value back, it may mean that no such value exists or that a type conversion failed. Good. So let me just sip a bit of water. And we get back to the next concept. So I've shown you now the getters, the setters, the type hierarchy, the introspection you can do. Now I want to show you the semantics, or that we have a reference semantics on the get objects if you're extracting a nested object. So what do we do here? I have a customer, and that's a JSON object whose name is Tom, and Tom is living in Paris at the moment. So it's quite an easy record here. And I am extracting the nested object called address. I know that address is an object, so I'm not going the route of extracting it as a JSON element T and then asking, are you an object, and then casting it to an object. I just happen to know that there is an object inside, so I just call get object here instead of just get. So that's the other thing to keep in mind. If you know your data, you can avoid a lot of this casting and introspecting by just providing an underscore, get string, get date, or get object in this case. So now I have my address. Now I'm printing my address, my customer. This is quite easy, not surprising. The address, the city is Paris. Now I update my city to Marseille. Now the question to the audience, just to check if people are still awake or not. What will, I mean, this is quite easy, right? I have changed my city to Marseille, so if I print my address, it will be Marseille. But what about customer now? So let's take a little poll, or just everyone can type now in the chat what they believe what's happening. And if there's no reply, I know that everyone is asleep. Yeah, Tom will be part of it. The same. Okay. Okay, so the same would basically mean Paris. It's actually Marseille. The reason is that if we do this get object, we are not creating a copy of the contents or of this address. We're actually pointing to the address inside here. This allows us to modify it. Otherwise, it would be quite expensive for every get to do a copy of the sub-JSON. So there's a performance aspect to it. And the other one would also be, how would you ever update something? You would have to kind of navigate all the way to the value you wanted to update. You would need something like path expressions, which we have on our to-do list, but which are not supported yet. So there's no way to say, do a put on a.b.c.d. No, instead you can extract these nested objects and work with them. So that's what we call reference semantic. This is quite different from, I think, all the rest of PL SQL, where you do have value semantics. So what if you wanted value semantics? Well, it's quite easy. This is the same example with the only difference that there is this dot clone. This also follows somewhat a naming philosophy of object orientation or Java. Now, if you do, the only difference is really this line. You do your get object of address, which is the handle to the nested object, and then you say clone it, which creates the copy. Now these two addresses are decoupled. This address will now not be this address, and now if you modify one of your addresses, it will not have side effects on the other one. So now you see Paris is the same. Obviously, this clone is taking up some time, not if your address is just very small like this, but if you work with megabyte documents and you're copying half of it, then this will need another half megabyte.
There's a comment there, says it is kind of inconsistent because non-object types behave differently.
Yeah, that's correct. It is a bit different. Inconsistent is a bit strong here, but it's different. But we actually saw no other way how to modify it. How else would you modify the city here if you don't have path expressions or anything else? But it's a correct observation. It kind of follows the way how you would code this, I guess, in Java, where you also have reference semantics on objects. But also not, it's only object and arrays, it's not scalar. If you do like a get varchar or a get number, you would obviously copy that into, or handle this like a normal PL SQL varchar or number value. And the reference semantics also only applies on read access. So if we do have, if we're writing something, here we have our customer, which does not have an address yet. We're creating the address separately, and we are putting the address into our customer. So then we're printing it. We have, what's the, yeah, this is the corresponding output. The customer now has the name and the address, which is Paris. Now we modify our address to Marseille. Then you see that the data of the customer has not been changed. So whenever you do a put, this value, if it's an object or array or scalar, actually will be copied. It's not a reference on put. And the reason, again, it's also quite natural. If you would have reference semantics on puts, then the same value could belong to different containers. You could have a value that belongs into two arrays or into two objects. And that, again, is quite unnatural. So the only thing really to keep in mind, which is what was called an inconsistency, or maybe somewhat difference, is that you have reference semantics on gets. Besides that, I think it behaves absolutely consistent to the rest of PL SQL. Good. Another thing, I'm just pointing it out, someone might want to create a table of these JSON object T's, and they will see an error message saying it's a non-persistable type. And now the question again is, why did we choose to make JSON object T, etc. non-persistable? Blaine, do you have any idea?
I don't get a vote in those types of questions. No, I don't.
Diplomatic answer. No, the reason is quite simple, because the persistable format of these things is JSON. It's the string JSON, and if you want to persist those, you just convert them to a string JSON using toString or toclob. It's a larger one, and that's is the data type you would use to A, persist it in a table, or B, to ship the data to a client. For example, if you work with JDBC, then JSON object T is also not a supported bind type. It would be CLOB or BLOB or varchar, because those are the data types that hold JSON. And these object types here, JSON object T, etc., they're really a means for in-memory processing or modification of JSON data. They're non-persistable, they're transient types. You use them to do some operations in memory. It's using C, so it's quite fast. And but you don't want to persist those beasts here. So now we're almost at the end. A few comments here. You don't need ever to free these objects. So you can imagine that if you parse a JSON, it could be quite large. Let's say it's a few hundred KBs. And you do things inside a loop, or you have a cursor of those things, that each of these instances may take up significant amount of memory. Well, it depends on the size of the data. We had a similar API for XML. It was called XML DOM. And XML DOM required you to do explicit free. So you had to tell the system when you were done working with an element. I think an XML is the right term. But here we've chosen another mechanism which is based on durations. So these, I'm not sure how much this is public knowledge, but in PL SQL, these values, if you define a variable that typically is associated with a duration, and if you pass it, let's say, to a function which has a longer duration, then some upgrade of the duration happens. And we piggybacked on this mechanism that the object keys and array keys are associated with duration, and durations can be added. And whenever the last duration ends, then we know that no one else holds a handle to this object, and we can safely free it then. So that really relieves the burden of memory management from the user, which I think is a huge improvement over having to do explicit free calls. Yeah, in these examples here, I've only chosen varchar values. So whenever you see a toString, this is actually a varchar output, but you could also use toCLOB if you want larger values to be returned. Obviously, there is a bit of a performance penalty if you use toCLOB. So you have to wisely use it for if you're sure you need it. Otherwise, if your data is small, just use toString. And yeah, I put the documentation in here. Let's just see if this link works. Exactly. So here you see these types. I've covered them all, including keylist. And you can just click on the type and you see the all the functions or methods that are supported on this type. You see the error message, raise all errors, etc. Yeah, so I think it's a small unit of code, and once you understood the concept of these elements and objects that they build object hierarchy, I think it's quite intuitive to work with this. And this script is live, so you can play with it as of now. And I'm done now, and I'm stopping sharing now, and we can now ask questions or. So is there, Blaine, is there anything in the chat which you believe we haven't answered yet? I see there is a statement 22 with a zillion exclamation marks. What was statement 22?
I think that was in reference to the answer to your quiz.
Got it, yeah.
And then there was a statement because the database would need a consistent structure for storing an object type. That was to your question, I believe, on why do we not have that as a type in the database? The object T.
It's a transient type. So I don't know when exactly we did it, whether it was 18, I think it was 18, we added these non-persistable types. Which have basically, if they're not only used for this, so you can, as a user, you can specify object types being non-persistable. I think it's just a keyword not persistable that you add to your create type statement. And one of the motivations is that you want to have these types for programming purposes only, because modifying these types is relatively easy. You would, let's say you add an attribute or you remove something or you change a data type. Then if you recompile your code, your packages, your procedures, then you're ready to go. But if you have it on disk, then then you need to decide how you bring these from one representation into the other. What do you do with if the structure has changed? That's what we've created these transient or non-persistable types for. And the question of persisting these JSON types actually never arose, because we do have a serialization form. So what's happening if you persist a type? So you have these are opaque types in the database. They're backed by some C structure, like some in-memory representation. And that in-memory representation might have a lot of pointers. These pointers may span an entire graph. And the moment you bring this down to the disk, you have to serialize it or marshal it or stringify it, however you want to call it. And that's pickling is another term for it. And for that, you need some algorithm which is able to turn this in-memory into a serialized format and vice versa. And we never saw any reason to do that, because we have JSON as the perfect serialized representation of this in-memory JSON data. That's why we actually requested the PL SQL to come up with these, or the object guys with these non-persistable types.
Question, can we insert JSON data with an insert statement into a table?
So that question appears to be a bit unrelated to this PL SQL, but yeah, you can just create a normal table. I could, let me just, let's just go, I'm going to, oh, now my session expired. I'm just going to show something on LiveSQL again. Let me share my screen again. Oh, I see, sign in. I just got kicked out of LiveSQL. And because I'm not on the VPN, it's probably now sending me a PIN code to my cell phone to log in. Let's see how this works or not. But the short answer is yes, you would say, I have a table. Oh, no, it's there. Got it. We can actually do this. Let me just share my screen again. Let's just see. So this is LiveSQL. For those of you that are not familiar, just Google Oracle LiveSQL or just LiveSQL, you should see this. And I'm just searching for JSON here. And there's this tutorial showing up at the top, the JSON features. And I just want to show you, let me just Yeah, so there is, exactly, it's right here. So this is how we create our table. And here we have a column called PO_document. Its data type is a CLOB. I could also have chosen a BLOB or a varchar2. And in order to enforce or to perform a syntax check to only allow JSON data, I add this check constraint here. PO document is JSON. And now in this tutorial, which you can easily run at home, we do an insert here. And it's the same way that you would insert any string into it. Like if you can insert a varchar, then you can insert a JSON. It's not any different at all. And these JSON check constraints just make sure that that is true. Let's see if I look for violated. Do we see? No, there's no example. But you would see that if you insert something that's not correct JSON, it would reject it. The check constraint would just raise an error.
Then there's a comment that says maybe it could exist a method to define JSON types with a fixed structure. They could be defined as persistable, something like an XML schema.
Excellent, excellent question. And it exists. And maybe that's something I'm going to show next time. It's the object type to JSON mapping. So if you specify an object type, not to persist it necessarily, but just as a means to specify the structure of your data, then, and if you instantiate that with some values, then you can easily turn that into a JSON. I think it's just JSON object and the object type instance as input. I do this. This is a good hint for one of the next AskTOM. Maybe I do this next time. Object types to JSON.